you're making a snowflake. I think it's Koch, right? That's how you say it. The comments have now been enabled on all my videos, I guess. So have fun. Don't be too naughty. So when you make a new pen or make a new replit, make sure you do the turtle one. Okay, we're using turtle again to help us with this. This is the Koch Snowflake demo. Okay, create. Nice. And since I have starter code, you should use it. So we go here and we can borrow this stuff here, copy and paste that into our new pen. Okay. So notice T here is your turtle object. So if we want to use this code, we have to define like Timmy, my turtle, equals turtle dot turtle.
How is he told that he is T?
Ah, great question. Now we use the function Koch and then Timmy, comma, and then n represents your length. So let's try 11.
Massive brain.
Turtle not defined. At the very beginning, let's import the turtle library and run it once more. Okay. Where is it? 20? I think it's just a line.
Well, you're not making him move.
Turtle should go forward when, oh, n is less than 10, right? So that should be like 9 or something. So,
There he is.
there is Timmy, okay? 9 pixels have been moved. Yes, very small, but it's working, okay? Yes, small boy. So that's your base case. If it's less than 10, we'll take our word for it that there's like 9 pixels worth of space over there. Now we go back to our assignment, okay? So we kind of got the base case. This is kind of blown up for our particular example. So it's a straight line. Talk soft. Okay. So that's our base case. That's like our starting point. And now let's see if we can do something that gets it to bend upwards, come back down. Okay. And then we'll worry about these later. But let's just get one step up, right? I want one bump. 1 point in my snowflake. And if you're looking at the hints, right, you got some more words, combine 3 of them to make another snowflake. Okay, and eventually we'll get here. If you highlight this text, you'll see a hint. Yes? Did you?
I didn't read it.
So at this point, you should definitely utilize my hint. That's what I mean. Don't take a marker to your screen, right? No. Highlight using click and hold. Okay. Right?
My 4K monitor's ruined.
Oh, darn it, Leo. Looks like you'll need another. I'll take your old one. Okay, copy. So let's try to follow this pseudocode over here. So code that's meant to help you. 1, 2, 3. So FYI, in Java, oops, I clicked the wrong button and now it all disappeared somewhere. Yeah. Okay, so down here, 1, 2, 3. The 3 single quotation marks, they could also look like this, like that. The double quotation marks, this is how you do a multi-line comment. So that's the equivalent in JavaScript, and I think Java, of doing something like that to comment, right? The hashtag is single line comment. In Python, it's the hashtag. In JavaScript, you're kind of used to doing that. So this is kind of useful too, the quotation marks. 1, 2, 3, and then 1, 2, 3. And Replit kind of auto-completes for you. So we're trying to implement these steps. Draw a Koch curve with length x over 3, turn left 60 degrees. All right. So down here, if n is less than 10, all right, we just go make a line. Otherwise, okay, we're going to call Koch, because that's how we draw our curve, with line x over 3. So in our case, it's n. That's the size. And you're still using the same turtle object. So you pass that in. Okay? And it's called t in this example. And now, we're down here. Okay. Turn left 60. Okay. Left turn. T dot left turn 60 degrees. And let's see what happens. Down here, yes. Let me move this stuff up here as I implement it line by line. Okay. So hashtag, we drew a Koch curve. Okay. Hashtag again, we turn 60 degrees. And I just add it on to my starter code. And then we'll move it up line by line. But let's see what happens so far. Try to zoom out a little bit. I'll move this window up. Okay. All right, I'm trying to fit most of this, and I'm just gonna click run. Let's see what happens. It may just go forward a tiny bit, right? Then over here, I need to change this. Maybe we'll do like 30.
But that's gonna be less than. That's not gonna be less than 10.
300.
That's still not less than 10.
So it just did a tiny turn, right?
Wow.
So if you play it again, it turned 60.
Well, like explain.
It did it 1, 2. So 300 divided by 3 is 100, right? So it did 160-degree turn. Then it called itself again. 100 divided by 3 is like still above 10, right? So it did 2 60-degree turns. 33 divided by 3 is 11. It did 3 60-degree turns, and then it stopped to draw a tiny bit of line. Right? So that's why you see it kind of turn like 180. So it's, wait, one left turn. Hold on. What's my initial direction? That way? Oh. 2, 3, something like that. Let's choose, 29? So you'll see, like 29, it caused it to go forward a bit, and then it turned a little. Yes?
Okay, yes.
So let's run that once more. Oop. Oop. Okay. And now let's implement more of this. Okay, so let's do that once more. We draw a Koch curve. Okay, we know what that looks like. Oops. Okay, so we paste that in, same line. Over here, we're gonna turn right. Okay, T dot left turn, right turn, 120 degrees. Okay, make sure the indenting is in the else statement. Let's implement the rest of this. Okay, hashtag, Koch curve again. Oops. And then we'll turn left 60 degrees. Almost there. Okay, we know what that looks like. Copy and paste. Now here, the exception is if x is less than 3, in that case, you just draw a straight line. Looks like we should have already had that, yes?
Yeah, I did the thing.
Yeah. That's the base case. So let's see what happens now. It's going to look real weird. Oh, what is that?
Oh my god, we have a pulse.
Yes, you have a pulse. Does that shape look familiar?
Yes.
Oh, does that tiny version as I zoom in look like what you started with?
Yes.
Oh my goodness.
So does that mean I gotta make it bigger? Yeah.
Yes.
How do I do that?
Yeah.
So now you must use your recursively defined function. Give me a number.
2.
Okay.
I'm not a good
I can make it smaller.
I have to zoom out all the way. Let's see what happens for 2. Where'd it go? Oh, there it is. All right, try picking a bigger number. 100. Okay. So let's see. 100. And then how do I get all this stuff to fit? I'm trying to zoom appropriately, right? So over there. Okay. Let's see. Ooh. Yes, and if you increase the turtle's speed, you will get faster drawing like Snowflake. You see it? It's very tiny.
Will that tiny
How do you
snowflake
make
give
it
you
bigger though? That's
Ah, good question. But you see the snowflake kind of forming, right?
yeah,
As you follow through the steps, it looks cool. And you'll work on the understanding of the recursion perhaps at another time. We'll just make pretty pictures. So let's increase the speed. At the very beginning, you can do like right where you have Timmy dot speed 100, and then it should draw it very fast. Woo. Okay.
Alright, Timmy. Oh my god.
All right. And the question, right? Like, oh, let's make it bigger. We can do that. You'll likely change this thing over here. Why don't we try 100? Okay. And now we'll keep this stuff the same. Let's see what happens. Run. Right? So then, yes, you still have the pulse. So then your inputs, because the input is a length, now it's being cut in thirds. Now that's your bigger snowflake, right? So it's much bigger. Zoom out, zoom out, zoom out. I've reached the maximum capacity of my screen, but like now that's bigger because that's your length, and you were just magnifying it by a factor of 10. You can add colors. You can go on to like do more ridiculousness. I'm going to change it back to something smaller so it can all fit because as you get more and more recursive, it looks neater. Okay, let's see what happens now. Where'd it go? Well, and we'll just let this run for a while. Not so slow anymore, turtle.
Oh wow.
And so have fun with it. Hopefully you make some modifications. Adding colors neat. You can change the spirit of it by doing other kinds of turns. As long as you fill this in, you will get full points. It's one example of recursive arts.
Going sicko mode.
Alright, Timmy. Your
So,
day is a big
That's my hint computer programming B. Looks like Timmy is just about done.
Belly still going.
Look at Timmy go.
Oh, wait, there's more,
He's
right.
still going.
Oh, but it's off the screen. I can't go anymore. Timmy, come back. Oh, where are you going?
Timmy, come back.
Okay. Maybe we'll just let him play for a while.
Timmy, I
There's about 9 more minutes left in class.
Scary come home.
Scary come home. Timmy, come home.
And then you can see why they made it 10.